Comparing two abacus methods. When the abacus first became a usable tool for students who read Braille, there was just one method for adding and subtracting. The method really didn't have a name at the time. It was just how to use the abacus. Eventually, this method picked up names like the synthesis or logic method to distinguish it from the counting method, which was introduced later. The synthesis and counting methods are both commonly used in Texas, and both methods produce accurate results. Neither method can be identified as the best way for all students to use. What are some of the factors you should consider when choosing an abacus method for an individual student? Speed is often mentioned as an advantage for the synthesis method, and sometimes this is true. However, students in both methods get faster as they develop skill, and the difference in speed between skilled users of the abacus in the two methods is not significant. The student's reasoning ability may be a factor. These methods do require different levels of abstract thinking. Teachers of younger elementary students are familiar with the idea of moving from concrete to abstract thinking. Very young children are considered concrete thinkers, and as they mature, their ability to use abstract thinking develops. On the abacus, the counting method is relatively concrete. One number is counted while one bead is moved. If 3 is to be added, the student adds 3 beads one at a time while counting 1, 2, 3. The synthesis method is more abstract. In the synthesis method, 3 beads can sometimes be added at once in order to add 3. But at other times, the student needs to set 5 and clear 2, or set 10 and clear 7 in order to add 3. If a student is either very young or has other influences making abstract thinking a greater challenge, the more concrete counting method may be a good choice. To illustrate the need for more abstract thinking, here are 3 example problems from very simple to more challenging. Let's look at the problem 3 plus 4 equals 7 in the counting method. 3 plus 4. Count 3 beads on the one's rod. To add 4, begin adding beads with a value of 1 with the expectation of counting 1, 2, 3, 4 while you add them. You can only add 1, at which point you run out of beads with a value of 1. Use the rule of 4, which says that if you have 4 set on the abacus and need to continue counting, exchange the 4 for 5 and say the next number in your count. So you clear the 4, set the 5, and count 2. The previous step frees up some beads with a value of 1. So return to setting these beads and count 3, 4. The abacus shows 7. Now what about that same problem in the synthesis method? Set 3 beads on the one's rod. To add 4, recognize that 5 can be composed of 4 and 1. To add 4, you can add 5 and clear 1. Set 5, clear 1. The abacus shows 7. Now let's look at a more intermediate problem. 19 plus 25 equals 44. We'll begin with the counting method. Count 1 on the tens rod and 9 on the ones rod. 1, 2, 3, 4, 5, 6, 7, 8, 9. The abacus shows 19. To add 2 to 1 on the tens rod, push up 2 beads one at a time while counting 1, 2. To add 5 to 9 on the ones rod, since no ones are available to add, follow the rule of 9 and set a 1 on the rod to the left and clear the entire 9. Set 1 and clear the entire 9 while counting 1. Then on the ones rod, move beads with a value of 1 up while counting 2, 3, 4, 5. The abacus shows 44. Now what about the same problem using the synthesis method? Set 1 on the tens rod and 9 on the ones rod. To add 2 to 1 on the tens rod, push up 2 beads at once. To add 5 to 9 on the ones rod, since no ones are available to add, recognize that 10 can be composed of 5 and 5. To add 5, you can set a 10 on the tens rod and clear 5 from the ones rod. The abacus shows 44. The third problem is probably the most complicated of these three. Let's add 64 plus 37 equals 101 using the counting method. Count 6 beads on the tens rod, 1, 2, 3, 4, 5, 6, and 4 beads on the ones rod, 1, 2, 3, 4. To add 3 to 6 on the tens rod, move 3 beads on the tens rod up one at a time while counting 1, 2, 3. To add 7 to 4 on the ones rod, first exchange the 4 ones for a 5 bead while counting 1. Then move beads with a value of 1 up while counting 2, 3, 4, 5. You need to continue counting to 7. The abacus shows 99, so follow the rule of 99 and set 100 and clear the entire 99. While counting 6, return to the ones rod and add 1 more bead with a value of 1 while counting 7. The abacus shows 101. Let's add 64 plus 37 using the synthesis method. Set 6 on the tens rod and 4 on the ones rod. To add 3 to 6 on the tens rod, push up 3 beads on the tens rod. To add 7 to 4 on the ones rod takes longer to explain than to do. Recognize that 10 can be composed of 7 and 3. To add 7, we could set 10 and clear 3. However, we don't have a 10 to set. I teach my students to clear the 3 now so they don't forget to come back and do it. So let's clear 3 now. We still need to set a 10 on the tens rod. Move to the rod on the left of the tens and set 1 there. This adds 100. Then clear 9 from the tens rod. This clears 90. By setting 100 and clearing 90, we have set the 10 we needed to set. The abacus shows 101. These examples illustrate the level of abstract thinking each method requires. The synthesis student must make accurate decisions at times about what to set and what to clear to add a number. The counting student simply adds 1 repeatedly, and when he or she runs out of beads with a value of 1, uses a small set of memorized rules to add the next 1. To those unfamiliar with using the abacus, the third example may make the synthesis method look far too difficult. In fact, it is not, and many students have been successful with it. However, it typically does take longer to master, as the student must learn what to clear after setting a larger number. The counting method has less to master. The third consideration in choosing an abacus method is a practical one. What is the student's need to work independently? If a TVI can work with a student daily and there isn't a great deal of pressure for the student to catch up to his classmates, then the synthesis method can be a good choice for a student ready to handle its more abstract steps. It is, in the end, a bit faster than the counting method. However, if a student needs to start working independently in a classroom right away, the simpler rules of the counting method may be easier to put to work independently. Students using the counting method also pick up speed and can work competitively with their print reading peers.